AP Statistics. This is Unit 1 still. This is our third discussion handout. And we are beginning a discussion on numerical data. Numerical data, like I said in class, is going to last a lot longer than the categorical data discussion. There's a lot of stuff we got to go over for this first unit on just numerical data alone. And we started with how to graph univariate numerical data sets. Now the word univariate, which I'll write that down, that's a very common word that we see in this curriculum, univariate, which basically is a fancy way to say it's a single variable that we're working with. So the data, it's a descriptor, an adjective for the word data. So a way to describe the type of data we have, univariate, and in this case, numerical data. So the entire unit, Unit 1, covers univariate data. But we can split those up into two classes. One is categorical, the other is numerical. Today we were concentrating on, or not today, Friday, it was a couple days later. So Friday, we didn't get to finish this one, and this one was covering the beginning of the discussion on univariate numerical data sets. So we started off with displaying them, and we introduced three different types of graphs. We looked at dot plots, stem and leaf displays, histograms. So what we do is we practice with the same data set how to cover or how to draw a dot plot, a stem and leaf display, and a histogram. We also talked about how to describe the shape of a univariate numerical data set given a display, and here we practiced with histograms. But we could also do that for dot plots and for stem and leaf displays. We can also do that later on. We're going to see with box and whisker displays. That's going to be another topic altogether that we're going to cover in the second week of class. The last thing that we left off on, which should take about 5 to 10 minutes, no more than that, unless I stretch it on by talking a lot and making sure you guys know the basics behind this, but it's a really simple topic, how to find the center, specifically the median of a data set. We're going to see on Monday and Wednesday that there are many types of centers, measures of center that we can calculate, and the easiest one is how to calculate the median. Unless the data set is extremely large, then we probably doing it by hand would be very, very difficult. We might need the help of a calculator, some sort of computer that we can maybe write a program to figure that out. Writing a program is not going to be something that we're going to need to know how to do in this particular course. Calculator is going to suffice. A TI-84 is going to be good enough. TI-Inspire is going to be a little better. So a graphing calculator, TI, will help and make that a lot faster. So let's talk about center then. We have our definition here, and in this case we're going to use the median. Median is literally if I arrange the data set from least to greatest or greatest to least. It can be done both ways. So as long as you arrange them in a particular order, either ascending order or descending order, we can find out what the middle value is, no problem. And let's say, for example, if I had the median, one of this data set, let's say my data set looked like this. 1, 2, 3, 4, 5. Let's say we had 5 data values, and that was it. Those were the values in our theoretical little data set. To find the median, now it's in order, from left to right in ascending order, and I need to find out what the middle value is. The middle value, in this case, you should clearly see, since there's 5 values, would be 3. So if you were to count 1, 2, 3, or backwards, 1, 2, and then 3, so it's the third value going up or down. That would be your median. So what you do is you take the number of values in our data set, in this case n is 5, our sample size is 5. There's a bit of a formula that you can use. You could take the value of n, you add 1, and you divide it by 2, and it's going to give you the position, quotation marks, position of the middle value. So n plus 1 divided by 2. So n plus 1 is 5 plus 1, which is 6. Divide that by 2, and we get 3. It's going to be the third one. So position number 3. So you want the first, second, third, going either forwards or backwards. It's going to work both ways if you count forwards or backwards. So the median in this case is 3. Now there's a bit of a difference if I were to maybe add 1 or take away 1 value in our data set. So let's say the number of datum values, or the number of data values in here would be 6. N is now 6. N plus 1 over 2 would now result in a 3.5, because that's 6 plus 1 instead of 5 plus 1. And you get 3.5 as a result. So if we get a decimal value like this, what that means is we're going to have to average the two integer values that are adjacent to that number 3.5. So 3.5, we have the integer values 3 and 4 adjacent to it. So you would want the third and the fourth is what that means. 3.5 means you want the third one and you want the fourth one. So we'll circle those two. That's not our median because those are two different values. What you do is you average them. And that's going to be 3.5 in this case. So coincidence that it's the position because I'm using the numbers 1, 2, 3, 4, and 5 in that order. If they were other numbers, then our average would look a little different. But it's the average of the two middle values. So that's how we calculate median. So here I have a bit of a set of instructions on how to do that, what I just described above. Maybe what I left out was the formula to find out the position of the median. And there's a symbol for the median, by the way. The symbol for the median, if I haven't put it up here, median is Q with a little 2 and subscript on it. It also stands for the second quartile, which we're going to define later. But the median is the second quartile of the data set. We're going to call it Q2. That's the symbol that we use for the median. So the position of Q2, the median, is equal to n plus 1 divided by 2. Very, very important formula that I left out, but I wanted you guys to write that. That's something you need. Number 2 is asking for us, so we spent an entire day on one problem, 3 parts A, B, and C, and those parts A, B, and C were different data sets. So it says calculate the median for the data in problem number 1. So the median for the data set in problem number 1. This is a much tougher one. And if you remember, I didn't write it down here in this case. No, not there. I wrote it up here somewhere. N is equal to 21. So N is equal to 21. And I want to find the median of this data set. So I had marked it off one by one that I was going for with a stem plot and with a dot plot. So since I already have the graphical displays, I'm going to be able to find out what that median is, no problem, just by looking at them. The only hard part here is if I try doing it with a stem plot. I had drawn this without worrying about what the order looks like. So these are not ordered. And maybe what I would want to do is order those, but I don't have to reorder them. So I'm probably just not going to do this on a stem plot. We can also do this on a histogram, which I'll show you what that looks like. So here, in order to try to figure out where the median is going to be on a histogram, you want to find out what these frequencies are. I think there was 1, 1, I did that in class. This is my 7th period notes, I believe. So those are the frequencies, 1, 0, so 1 here, which is 1 here. This one was 0, 1, 0, 3, 3, 8, 5. So we had a 21 value data set, so n is equal to 21. So then the position, which we don't write the full word position, there's another symbol for the position. You could say D of Q2 if I wanted to get a little more rigorous with the mathematical symbols. This is n plus 1 divided by 2. In this case, it's 22 divided by 2, which is 11. I want the 11th one. So where's the 11th one counting this way? There's 5 data values here because the frequency is 5. There are 8 values here because the frequency for that bin was 8. So total, combining these two rectangles, there is a total of 13 data values. So what does that tell me? That tells me the median is in here. So our median is found between 160 and 169, including 169. Not including 170 because 170 is the next bin. So it's somewhere between 160 and 170. So if I were just doing this based off of a histogram and I didn't have what the data was, Q2 is somewhere between 160 and 170. So notice how on 160 I'm including the boundary, 170 I'm not. Because it can't be 170, it's got to be a little bit above 170. So that's what I would reason the median is going to be for that particular data set. So that's one thing I'm going to be looking at on Monday in more detail. How to calculate median of a data set based off of only the graphs given. So if I did this on the stem plot, I would want the stem plot to be ordered, and it's not, so I'm not going to practice that, something we'll look at Monday. The dot plot's going to be a little bit more straightforward, a little easier to see because you see straight dots. So you can count from left to right or right to left, doesn't matter. Since we're working with the same data set, 21 values, it was number 11 that was the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's the 11th data value. So that should be Q2, or median. We can also count backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you go this way, that would be number 11, which is any one of these three. So it's going to land us at the same spot. So that is our Q2 value. And what value was that? Is that 162, 163? I don't remember which one was the one that showed up all those many times. So I see 162, and if it's 3 times, I think it's that value. 3 times. Do I see anything like 163? Because I drew that kind of close, and the window size wasn't big enough for me to be able to tell if that's exactly 162. It could be like 163 the way it's at, or the way it's set up, but I see no 163s, so my guess is Q2 is equal to 162. Now, what's the surefire way to like make sure that you get it right? You're going to order these data values from ascending or from least to greatest, or you can do that in descending order from greatest to least, and then you literally count, find where the 11th one is, and it should be 162. So that's our Q2. So I'm going to write that here. I'm going to report it where they wanted it. Quite a bit of scrolling. So the median for that data set, Q2, which is median, is equal to 162, and that's species if you remember the context for that particular problem. And that's literally how we find the median for a data set. And that's pretty much it that I want to go over today. What I'll probably do is I'm going to cut this problem out from this particular handout and include it on Mondays. Now I'm seeing kind of the way I want to structure Monday's handout right now that I'm going to be writing it. I will go ahead and include how to find the median for something like this, which takes a little bit of time to explain. So here I got a little ambitious when writing this particular handout. This extra problem should have been included for the next one. So be looking out for that one on Monday's handout.